Now we're going to explore some applications of trig functions, of acute angles and right triangles, and yeah, get to have some fun. Now, when I work through these, I kind of go through a process. First, I always have to get a picture. For some reason, my brain operates much better if I can get a picture. After I get a picture, I try and label different quantities. So label quantities. This just helps me understand what I'm working with. Uh, Third, I find an equation that will help me. In this context, we're probably going to use a trig equation. And then after, I solve. So if you're stuck, try and go through this general process. Usually the picture goes okay and we get stuck with labeling the quantities. Because without proper labels, then we can't set up an equation. So really take a hard look at your labels that you use. All right, so here we go. We have a 15-foot ladder leaning against the wall. Okay, so here is my wall. So I'm just going to write wall. Let's see, and we have a ladder. I'm just going to indicate that with a straight line like that. We know it's 15 feet. So it's leaning against the wall at an angle of 62 degrees with the ground. Okay, I need the ground too. Here's the ground. I'm going to say this angle in here is 62 degrees. So I'm kind of doing pictures and labels at the same time. How high up the wall will the ladder reach? Okay, so we're looking for, right up here, how high that is off the ground. Okay. So let's see, I have picture, label. I don't know what this is, but it's vertical, so I'm just going to say it's y. I want to figure out what y is. Okay. So I've kind of done steps 1 and 2 here. And now I need to get an equation. My equation is going to try and relate the knowns and unknowns. So I know the acute angle, right? I should also mention that the wall, we would normally assume that a wall is perpendicular to the ground. If it isn't, might want to call a contractor and get that thing braced. So we're going to assume it's perpendicular. So with respect to this angle of 60 degrees, I would have the opposite side unknown and the hypotenuse as known. And so in that, since I know the angle and I don't know the opposite, but I know the hypotenuse, I would use sine. So I do sine of 62 degrees is equal to my unknown y over 15. Okay, and to solve for y, right, I need to get rid of the 15, so I'd multiply both sides by 15. Okay, so I get 15 times sine of 62 degrees is equal to y. Okay, and at this point, we'd have to leave our answer if it was asking for an exact value, but since it's saying round your answer, let's go ahead and get our calculators and punch this in. If we do, we get about 13.2 feet. And then lastly, to conclude, this is a context, right? You can imagine this in the real world. So we're going to write a sentence. We're going to say the ladder meets the wall 13.2 feet from the ground. There's our answer. Okay, so again, just to recap, start with a picture, which I did. So I had the wall, and I should maybe include the label of ground. And then I had the ladder on there, which is 15 feet, angle of 62 degrees from the ground, and we're looking for the height along the wall. Okay, so I had a picture, labeled some quantities. The equation I used was sine, and then I solved it. I solved for that opposite side in my triangle. All right, so here we go. The next question is going to deal with angle of elevation and angle of depression. These are commonly misunderstood quantities, okay? When we talk about these angles, okay, they're from an imaginary horizontal line. So imagine this is like the imaginary horizon line. I'm going to call it horizon line. It doesn't really have a name. I'm just going to call it that. Okay. And so imagine like this is your eyeball. Okay. So here's your pretty little eye with the eyelashes, right? But this is your eye and you are looking straight out towards the horizon as far as you can see. Okay. If your eye has to look upwards from that horizon line, okay, upwards from that horizon line, that is elevating, right? So that's why we call the angle that is upwards from the horizon line angle of elevation. Okay, so it's always with respect to wherever this line of sight is, or this horizon line. Okay, upwards is angle of elevation, and downwards you might guess is angle of depression. Okay, so again, horizon line, and if you have to, if your eye would go down from that horizon line, you would be talking about the angle of depression. Okay, so here's our next example. Farm worker, blah, blah, blah. Okay, here we go. Okay, so the farmer, right, is saying that from their eye level, from her eye level, right, which is already 5 feet 4 inches high, okay, they are looking at a tree. So here's the tree. Terrible tree. You get the idea. But the tree is 16 feet away. Okay. And now for her, if she were to elevate her eye, right, to the top of the tree, that is 36 degrees. So right in here, this is 36 degrees. That is our angle of elevation. We're assuming that the tree is perfectly straight up and down too. Okay. So we want to know how tall the tree is. So that would be this total distance. This is the height that is unknown. Okay. I technically already know that from like directly from her eye on down is 5 feet 4 inches, which if we convert that all to feet, that's 5 1/3 feet. 12 inches in a foot, remember? So there we go. We just need to figure out how much is this additional bit. Why? Okay. So I have a diagram. I have some labels. Now I need my equation. The equation needs to relate the angle, the unknown, oops, undo that, the unknown, and another known, which is another side of the triangle. So angle opposite and adjacent, which is tangent. Tangent at 36 degrees. Okay? And this would be equal to y over 16. Solve for y, multiply by 16, multiply by 16. And so we have 16 tangent of 36 degrees is equal to y. And putting this in a calculator yields 11.6 or so. Okay. It doesn't say exactly how to round. We're going to assume it's 1 decimal place like the previous one. Okay. So then h, right, the total height of the tree would be 5 1/3 plus 11.6, which again, I'm rounding here, I'm being generous, but it's about 17 feet tall. Okay. So I'm just going to say the tree is 17 feet tall. Okay. Now, a common question I get is, well, do I have to use 36, right? What if I put the 36 here? Okay, I'm going to put this in red. 36 here. Okay. Well, you're going to, in some instances, you could be close. Other instances, you're going to be way off. This one, you'll probably be in the same ballpark. But what will happen is if you do tangent at 36 degrees, you'll have to set it up like kind of the reciprocal. So actually what you're using is not tangent, but cotangent. Cotangent would yield the same result, but you'd solve this. So in this case, you'd get multiply by y, multiply by y. So you'd have y tangent. This one has a little bit more algebra. 36 degrees is equal to 16. And then divide by tangent. So y is equal to 16 over tangent of 36 degrees. So you'd have to number crunch that, and you'll be off a little bit. And so your final answer might look a little different, but conceptually you are wrong, because this angle of elevation is from the eye on up, or from a certain perspective on up. The angle that you're listing here would actually be the complement, right? Or it should be the complement. So 54 degrees, right? Instead. So just be careful when you're setting that up, that you're always using angle of elevation and angle of depression appropriately.